Okay, let's continue chapter 4. So this will be the fourth part, the fourth video for the chapter 4. Okay, so today we will talk about the second type of the reaction in solution. You know, in the last class, we introduced a reaction called precipitation. I showed you a lot of videos. Basically, for that reaction, you can see some solid stuff in soluble compound form. But today we talk about the second type called acid-base reaction. So please also remember another name called a neutralization reaction. You know, you have acid and you have base at the beginning. And then when you put it together, they become neutral. It's not acid anymore, it's also not base. This is why acid and base is called a neutralization reaction. So before talk about the reaction, we will review some knowledge. You know, before, during the naming, I think I briefly mentioned what is acid and what is base. Then today we will go deeper. We will provide two kinds of the definition. One is called Arrhenius definition. So according to this Arrhenius definition, so the acid will be the substance that can produce hydrogen ions in aqueous solution. So you know, before, like the nitric acid, for example, can separate into these hydrogen ions and also nitric ions. However, in water solution, in reality, these hydrogen ions actually combines with water, form this kind of the ions. Yeah, because it's this in the water and they combine in that format. So this way we give a name like a hydronium ion. This hydro, you know, is always related to water. So hydronium ions, the real form exists in the water. In other words, in water, you don't really see these separate things, but they combine with water. Yeah, again, like the nitric acid, so put into the water and form these hydronium ions and nitrate ions. So let's take a look at our video.
When nitric acid, HNO3, encounters a water molecule, it forms an acidic solution by donating a proton, the H+ ion, to the water to form a hydronium ion and a nitrate ion.
Great, hydronium ion and nitrate ions. Okay. So, what is the properties of acid? I think the one acid everybody knows is a vinegar, right, in your kitchen. So first you can taste it's kind of sour, right? When you eat some salad, you put some vinegar, that's kind of the acid. And the second one, I'm not sure if you know, the acid also conduct electricity. If you want to do some experiments, you can buy some battery and bulb and connect it with electrical wire, and you will see the acid can conduct electricity. The third property is very important. This acid Arrhenius acid also always can change the color of the litmus to red. So this litmus is a kind of we call it the acid base indicator. Yeah, just because acid can change its color, so we use that one as an indicator to tell you, okay, that solution is acid or not. So can change this litmus to red. Another property is acid can react with many metals to produce hydrogen gas. We use many metals, but we didn't see all the metals because only the active metal can react with acid. We will talk about that later. This kind of active metal, for example, like zinc. This year, I'm not sure you will do virtual lab or not, but if it's the regular metal, you will do this experiment. You put the zinc into the acid, and then it will form this zinc sulfate plus the hydrogen gas. So this is the property of acid. How about the Arrhenius base? Arrhenius base is a substance that can produce OH ion, hydroxide ion in aqueous solution. Very good example is sodium hydroxide and dissociating to sodium ion and OH ions. So this is a picture showing you. When you put this compound like the crystal into the water, they will separate, dissociate into the two ions. So the property of base, you can taste the kind of bitter taste. Also, how to say, some soap, yeah, in your bathroom, you see some soap, or even some hair detergent, and they taste a little bit. You can use your hands, feel it. It's a little bit slippery, yeah, slippery. It's kind of base, and also this one can conduct electricity, just because, like the previous slide shows, that compound can, sodium hydroxide can dissociate into two kind of ions. It's ions that conduct electricity. Yeah. Basically, any compound, if they dissolve in the water, they can form the ions, then they conduct electricity. So this base will change the color of litmus to blue. Do you remember how about acid? Acid changes one to red, but the base changes this one to blue. This is why I said litmus is a very good indicator to test some solution if it's acidic or basic. Because we cannot use our mouth, we taste something, for example, then we may die, hurt our tongues. Yeah, this is why we need some indicator. So now, the previous example are very classic but simple example. Now I would like to challenge you about one question, using this one question. Is ammonium an acid or base when dissolved in the water? If you tell me acid or base, you should let me know the reason why you think it's acid and base. Because it looks like we have hydrogen here, our first impression may be, it seems this one could be acid because you have hydrogen, right? According to the Arrhenius definition. If this one can produce the hydrogen ions, it will be acid. But the truth is, when this one dissolves in the water, the solution exhibits the property of base, not acid. So why? Because according to the Arrhenius definition, if the substance that can produce these ions in solution, we call it a base. Then let's see what kind of the ions. It's hydrogen ion or hydroxide ions ammonia will produce. Let's see. So when we put this ammonia into water and they form these two ions, it seems this water provides one hydrogen and combined with this ammonia form this one, right? because you get one more hydrogen here, and water lose one hydrogen, form this one. You see, the result is when you put the ammonia into the water, the result is you have OH ions in solution. So according to this definition, this one is base. Yeah, the definition is a substance that can produce OH ion. Ammonia, it is producing OH ion, right? Ammonia is base, yeah. So now we introduce another type of the definition called Brown state definition of acid and base. So this definition says the Brown state acid is the protein donor. So anything can donate proteins, yeah, is acid according to this new definition. And the Brown state base is a protein acceptor. That means a substance that accepts the protein will be called a Brown state base. That is a broader definition than Arrhenius. For example, there's no conflict here. If this one is acid according to the, yeah, this one's acid according to Arrhenius definition, but it's also a Brown state acid here, because this one, you see, donate one protein. This protein donated to water, make the water like this. You see, this lose one hydrogen ion. Yeah, donate hydrogen ions from here to here to water. This is why water becomes hydrogen ions, and this nitric acid become nitrate ions. Okay, this is according to this definition. Yeah, so this is a hydrogen donor is acid, and the hydrogen ion acceptor is base. Let's come back to the ammonia. For ammonia, in this case, you see ammonia accept one hydrogen ions, you see, from water. According to the definition here, protein acceptor is base. This is why this one is acceptor is base. You see, so it seems this Brown state definition is better in terms of the explanation of ammonia. Yeah, directly use the concept of the hydrogen acceptor or donor.
Ammonia acts as a base in solution by accepting a proton from a water molecule. This liberates a hydroxide ion and results in a basic solution.
Yeah. Okay. So for this slide, it's relatively simple. Tell you some different acid. One term we called a monoprotic acid. Like before, I said this mono usually is mean single or mean one. Yeah, it's not multiply. Yeah, multiple, not multiple. So this, from the definition, monoprotic acid means that acid only can donate one hydrogen ions. This we give a name like a monoprotic. Yeah, only can produce one protein. Yeah, so monoprotic. It's understandable. Like this acid, and yeah, you see here. Okay, sorry. Only one hydrogen here. Only one hydrogen here. This is why called monoprotic acid. I think easy way to judge it. Another one called a polyoprotic acid can donate more than one protein. easy way to judge is if you see some lowercase number here, you see, that means it's polyprotic acid. If you see no that number, that means only one, that will be monoprotic acid. Anyway, you should get familiar with this wording. Yeah, when people talk about that with you, you know polyprotic acid, what does it mean? Yeah, that means you have more than one, either two here or you have three here. People also give another name to distinguish these two classes, like this one is diprotic. Here, two is mean di. I think I talked about that before. Di mean two, and like a triprotic. This tri means three. Yeah, like a triple. You know it. Yeah. So another category we can separate acid is we can separate acid into strong acid and strong base in comparison with a weak acid and a weak bases. So what is a strong acid? Strong acid means that acid or base can ionize completely in water. This, we learn ions. That means that acid or base can dissociate into ions. This is what we call the ionized. Can separate into ions completely. Yeah, they are strong electrolyte. Yeah, you may recall we learned strong electrolyte and non-electrolyte and weak electrolyte. If that one can completely dissociate into ions, that means the concentration of ions will be high. Of course, will conduct electricity better. This is called a strong acid, like this. Strong base, they 100% dissociate into ions. But there are some acid and base, they only partially dissociate into ions. During that time, we call them weak electrolyte. Do you remember? Yeah, weak electrolyte. Mean only partially. I showed you some video for. I remember we use ethanol. Yeah. Oh, this one. Yeah. Then they dissociate into ions, and then they recombine. The ion recombine into the molecules. So there are two reversible processes. So this is called weak. Anyway, it's not 100% dissociated into the ions. This is why they are conductive, but not highly conductive. Not conduct electricity very much. So we call it weak acid. Okay, now let's see what is acid-base neutralization reaction. Sometimes called acid-base reaction. So according to the the two definitions like Arrhenius and Bronsted, yeah, this acid can produce this hydrogen ion, and the base can produce this one. So if we add the base and acid together, if that means you combine this one together with this one, you see you will have two hydrogen and one oxygen. That will produce water molecules. Yeah. So as a second product will be salt. So salt is an ionic compound where the cation is not hydrogen and the anion is not OH ions. So that we call salt. Salt is ionic compound that, because if it contains this one, we will call them acid, right? If it contains this one, we will call the base. Yeah, we will not call them salt. This is why it's defined like that. Whereas not, this one will be called salt. So let's take a look at the monoprotic acid reaction with a base like this, you see. And before when we talk about the ionic equation, we said to write this kind of the double exchange reaction, we change a partner. For example, now this student will recombine with the partner from another group to form this one. Of course, when you do that, you should put a positive ions on the left and the negative ion on the right. And this one, hydrogen will combine with this one to form water. Yeah. Some students write down like HOH. It's not good, not professional, because HOH is the same with this one. So why not use H2O? Because that is well accepted and professional and standard writing for water. Yeah. In this reaction, this is acid and this is base. This is salt, what we eat in our kitchen. You can buy it from the supermarket. So in this case, the hydrogen ion is transferred from acid donor to the base, the hydrogen acceptor. So this is called an acid-base neutralization reaction. So let's review our previous knowledge, write the ionic equation for that. We first write the ionic equation and then we write the net ionic equation. So before doing that, let's take a look at the molecular equation, right? Molecular equation, that means everything is written in the molecular form, like this. This acid plus this base, this polyprotic acid, like we said, and then we'll produce the salt and the water. So this potassium ion will combine with these phosphate ions. But you have to consider this one is 3 negative charged. This one is 1 positive charged. So when you combine these two, you have to put 3 here in order to make this new compound neutral. Yeah, 3 positive 1 means 3 plus, 3 negative. Yeah, okay, neutral. And then this, this one will you will take one of these combined with this ion, form water, but it's not balanced yet. And then you balance it this way. You see, you have 3 hydrogen ions combined with 3 OH ions, form this 3 water. So why we do that? I found some students do it another way. For example, they use these 3 hydrogen ions combined with this single one. That is not correct. They end up with H4O like that. It's wrong. Why is wrong? Let's take a look at the ionic equation. For writing ionic equation, like we said, we separate any compound that has a state symbol of AQ, mean soluble in water. If I separate this one, I will write this one in this form, 3 hydrogen ions. Why not write down like 3, like H lowercase 3 here? No. If you write that way, which means you are talking about that one ion is a polyatomic ion. That one single ion composed of 3 hydrogen is not correct. Because in the water, we only can find this hydrogen ion, not hydrogen, not H3 ion. We find hydrogen ions, but we found 3 hydrogen ions. Yeah, I hope this is clear. But if you have questions, yeah, please ask me after my class. So and then we separate this one to here, and don't forget to label the charge and also the state symbol is AQ, and we just copy here. And this one separate into 3 potassium ions, yeah, and we have 3 OH ions. From here, you can see if we write, this one will, single one will combine with one single one, form one water. And you have three, you will combine with this three, form three water. This is why, as I said, you cannot use these three hydrogen ion combine with one of this one. You end up with H4. Oh, it's wrong. It's incorrect. Yeah. I think this one is quite clear. Yeah. Each one combined with this each one. And this ionic equation, again, for net ionic equation, we simply cancel out the common atoms on the both sides, on the left and on the right side, because on the left you see this one, on the right side you see this one. They are identical. So, and I will cancel them out. And what left over on the left is hydrogen ions and OH ions. I just, just copied, and then the water also copied down. And water we use L mean liquid. Yeah, this water we cannot really separate them into ions because they are remain in the liquid form. If you write down like this, it's not 100% correct because it's not really wrong, but it's not really professional. Not the best. The best answer will be this one. Perfect answer. Because these three can be cancelled out, right? If you divided 3 on the left of this equation, also on the right, you will. This is some final, answer for this net ionic equation. So for this acid and base reaction, one thing we want to mention is sometimes this kind of the exchange reaction will end up with a gas formation. Normally this happens when the product is the unstable acid. For example, if you have this carbonate ions react with this acid, that means this salt may contain this kind of carbonate salt, like potassium or sodium or something. And then you react with some acid, you form this unstable acid, we call it. This unstable acid will decompose into CO2 and water. Yeah, actually, this is a reaction for when you drink a soda. You drink soda water, right, in the supermarket. Yeah, there's lots of bubbles when you open the cap. That bubbles CO2 gas. It's based on this principle reaction. Yeah. So the example is, if you have this acid and you have this ionic compound, and then you change the partner, so they will become potassium chloride, and another, you combine this one with this one, and you need 2 hydrogen combined with this CO3, and you form this new acid, but this acid is unstable, will decompose into this. Yeah, to form that. Of course, I want to mention the soda you drink is not this reaction because we cannot use this strong acid. Do remember this is strong acid, can burn your throat. Normally we use a vinegar, and we use a vinegar, and we also don't use this one. Yeah, we use like a sodium, carbonate or sodium hydrogen carbonate. So other reactions that with the gas formation involved, typically it's like this, for example, kind of acid. Instead of the carbonate acid, we also could have this like salt, like sulfide ion react with acid, form this gas. Yeah, this is also gas because this one is unstable. And another type of reaction, as long as the acid formed is unstable, they will decompose into gas, or if this gas have a very low solubility, one is formed, it cannot be held in the water. Water cannot hold this acid. So this one just evaporate into the air, form the gas. So I think this is a very important slide, even seems simple. To make a solution reaction happens, the formation of a compound not dissociated into ions is required. It's a pre-requirement. In order for the reaction happens, there must be some compound formed, and that compound must not dissociate into ions. What does it mean? That means that product compound either should be precipitated, like what we learned, or the video see, like insoluble compound form, or should form some water, or should form some kind of gas, or you form the molecules that are not dissociated into ions. And you may ask why? Because if a reaction has a precipitated product, then you can use a filter to take it out. And if you produce some water, you can evaporate the water, get a product. And the gas, you can collect it, right? And if you have molecules, then you also can separate them. However, if there's no this kind of thing form, that means the reactants, that means nothing, product, you can take it out. The reactant will be the same with the product. I will show you some example. If you form this one precipitate, like I said, you can use a filter to take it out. And if for the neutralization reaction, you form the water, right? Then you boil in the water and evaporate it. Let it evaporate it, and then you can get a product. However, let's take a look at this case. This case tells us there's no these four type of things happen. No precipitate, no water, no gas, no molecule. Let's see what happened. Sodium chloride react with potassium sulfate. And we change the pattern, you get the sodium sulfate because the pattern, this one, exchange with this one, And this one recombined with this one. So this is a molecular equation. If we write down in the ionic equation form, let's separate this one into sodium ion, chloride ion, potassium ion, sulfate ion. Okay, this is a reactant, right? Okay, let's take a look at the product. Separate this one into here. Sorry, it's not balanced. Okay, sorry. This should have two in the front. Okay, two in the front and two in the front. And so then you see that if you compare these reactants have exactly the same ions as the product, that means nothing happened. In other words, if you add in this compound solution into this compound solution, after you added, nothing you can take out from the beaker. That means at the beginning you have these ions in the beaker. At the end of reaction, you still have these four type of ions in the beaker, but you cannot do anything, take out anything, because there's no precipitate, no water, no gas, no molecule. Basically, this reaction we call a no reaction. It's not a really reaction. Nothing happened, no reaction. Otherwise, the ions before and after the reaction are the same. No reaction happened. So in the future, in the exam, we may test you. Okay, we give you some, like the two reactants. We will ask you, will some reaction take place or not? Yeah, you will see if there's no these 4 type of things happens, you will see there's no reaction happens. Yeah, for reaction happens, you must have at least one of these product involved. Okay, I think we stop here. We stop sharing. Let me see.